Another important concept is the Frenet-Serre frame, or TNB frame. This consists of three vectors derived from the parameterization of R of t. We have this t of t, n of t, and b of t. We already know one of them, so we're done there. T of t, done. So the unit normal vector, this requires that t prime of t does not equal 0, the magnitude of it. In other words, the curvature can't equal 0. This is just going to be t prime of t divided by the magnitude of t prime of t. Pretty simple. And then the binormal vector is just t cross n. Done. That's all we need to figure out for now. Some good information about the TNB frame is since the magnitude of t is equal to 1, then t dot t prime of t is equal to 0. So t is orthogonal to the normal vector. And by the definition of the cross product, b is going to be orthogonal to t and n. So all three vectors are orthogonal to each other. Since the magnitude of t and the magnitude of n are also equal to 1, we have the magnitude of b, which is equal to the magnitude of t cross n, which is equal to the magnitude of t times the magnitude of n times sine of pi over 2, since they're orthogonal, is also equal to 1. So all of these are unit vectors, which is very nice. Sometimes they can be hard to compute, this kind of method, so here's an alternative way to calculate b of t. It is r prime of t cross r double prime of t over the magnitude of r prime of t cross r double prime of t, and n of t would just be b t cross tt. N always points in the direction the curve is bending, and b is pointing orthogonal to the motion of the curve. We're hopefully going to have some Mathematica examples to kind of show. There's some very interesting animations that you could look up, just TNB frame animation, that would be very nice to be able to look at. So let's use TNB frame and create some planes using R, T, N, and B. The normal plane, this is the plane that is perpendicular to R of t. It is determined by n and b, so t is a vector orthogonal to it. Then the oscillating plane, this plane best captures the motion of the curve. It is determined by t and n, and so has b being the vector perpendicular to it. And the rectifying plane, this plane is determined by t and b, and we won't even bother to look at this one. So why are we pointing out which vectors are orthogonal to it? Well, remember that in order to figure out the formula for a plane, we need an orthogonal vector to that plane.